Namaste, I'm Raj Vedam and I'm going to be talking about the deep history of the Bharatiya civilization. I've always been interested in the history of science, technology and what role Indians had to play in the history of science and technology. And that quest has led me to learn about a whole lot of things in our history. And I came to some disturbing facts that our history is not taught the way that we should be learning it. And so I started accumulating this information and I'm giving lectures of this nature. So in this series of lectures, I will bring out several scientific facts that talk about the history of the Bharatiya civilization. We are all about evidence-based. Nothing that I'm saying is an opinion and somebody's big opinion that we are privileging over here. That is not how we function. We are analytical people. We are logical people. We are rational people. So we want to look at the evidence. We want to look at what is the models you've used, what is the methodology you've used, what kind of claims you have, and from that we come to a conclusion on whatever it is that you're trying to claim, we analyze that. So that said, let me start with first our respects to the Gurus, Om Shri Gurubhyo Namaha. So this is our citation trail. We owe all our knowledge systems to our Gurus of the past, our teachers of the past, and several teachers of the present. My pranams to all of them. So today we're going to be doing two lectures, lecture 1 and 2, where I'm trying to show what science shows in the antiquity of human presence in India. Prior to that, we'll talk about origins itself, how old is ancient man in India, and we will deal with the archaeology model and the paleontology model. These are the two models that we will discuss over here. First of all, when we talk about historiography, the process of writing history, we should know that in this civilization, we have been very happy with the Itihasas, with the Puranas, with the oral records, epigraphy, folklore, songs, writings, dance, family genealogies. This has been our traditional understanding of history and has satisfied us very, very well for a long time. Then we have got, from Islamic times at least, when they had chronicles of their rulers, we had some kind of notions of history the way they wrote it. And we got the Whig interpretation of history viewed through the prism of Christianity as a moral force on which all of history is evaluated. So the problem with this interpretation of history is, if it tries to look at every social aspect or happening in history through the prism of Christianity, the morals of Christianity are applied to the world, clearly it is going to lead to a bigoted and all kinds of wrong notions of history, if you will. But then this is a notion of a Whig interpretation of history that has taken root, and our academia continues with this kind of a notion of history. Then today we also have presentism. Presentism is judging all history through the value systems of the present, and we find there is a tendency to do that in several people. So we got to ask, is it more of sociology you're talking about or history? But anyway, presentism is part of what people do today. In contrast to these, I am bringing over here evidence-based, model-based history because I'm a scientist. So the language that I talk is always in terms of rational, logical analysis of the data and the facts and the evidence and come to a claim or conclusion. So that's how I work. So we are going to examine everything in these series of lectures with evidence-based notion and model-based notion. You might wonder, what do I mean? How do we study history through models? Well, models are our attempt to understand a phenomena. If I'm looking at some phenomena in nature and I want to understand how is that working, I'm going to have some imagination and say this is how it works. Some data is going in and there's something happening here and something's coming out of that. For example, if I turn the accelerator in a scooter, it is going faster. So the model for me is that when I turn that accelerator, something is happening with the petrol in the engine and it is going faster. That is the model. So when we study the history using models, we are using an age-old Indian darshana called Vaisheshika. This is based on perception and inference. What do we mean by that? Rishi Kannada said there is external perception and internal perception. And external perception comes through our interaction of the world with our sense objects, and internal perception is through our understanding, through our mind, and so on. He advocated both of them, though external is not that reliable as opposed to internal perception. So we had Pratyaksha and Anumana. Anumana was a process where we tried to build new truths by understanding the old truths and trying to construct something new out of that. This is exactly the scientific process we are following over here. We are trying to see in every aspect of this history, what is the model people have studied, what is the phenomena they have, and trying to see can we get new information out of that, and that's what we're doing. A good model accommodates all the evidence coherently with little or no conflict. So I say that there is a whole lot of data for history. You just have to go looking for it. If you were to look, for example, at archaeology, genetics, epigraphy, coins, climate records, astronomy, literature, oral records, foreign traveler accounts, sciences, script, grammar, religion, philosophy, arts, cuisine, culture, dress, paleontology, paleobotany, so many fields are there which give us data to talk about history. Now, when we have so much of data, our issue now is how do we analyze this data to have some inferences on the Bharatiya civilization. So for that, people have proposed many models. And one of the models is the linguistics model, where they try to take the different sounds, how sounds are formed, and try to make a relationship between different languages to try and understand who are the different people who speak related languages. That's a linguistic model. Then we can have the archaeology model, where people can dig up the material artifacts from some layer in the soil and try to make an inference about the people who lived there and the kind of life they had. Or we can have the genetics model, where I can take a look at all the mutations that I carry and try to see where did I get those mutations from, where were the ancestors from, and try to trace a record of where they came from. Or you can have an astronomy model where a whole lot of data in our text, the Brahmanas, Aranyakas, Upanishads, Itihasas, they have all got a whole lot of astronomical information, and we can use that. So a good model should explain the context multidimensionally and should be used to predict, to fill the gaps. That is what we would like a model to be. So we should understand that there are different sources of data. Source 1, source 2, so many different sources of data like I showed you in the previous slide. And we cannot use the data directly, right? Because we don't know where the data came from. Or it might be noisy data, or there might be some issues with the data. So we have to do some analysis. And typically in engineering, you do some filtering, processing, interpretation. Make sure you can use that data for what you want to do. Once you have done that, then you have your model. Your model could be the linguistics model, a semantic model, a logical model, a mathematical model, like in genetics, whatever. So you use some methodology over there. Once you do that, you're going to get some results, which we call inferences. You're going to make some inferences from the model's behavior with the data based on the frameworks that you're applying. These are the drishti that you bring to the situation. What are you looking at in the Bharatiya civilization? And you can make some decisions based on that. So that is what we want to do. So we have to do some critical thinking over here. So first question, is all data equally valid? We know that some data is of pretty high quality, some data is of medium quality, some data is of low quality. We need to understand that. Then we have to ask, is the data reliable? Then the provenance of the data, where did it come from? Sometimes it might come from an unreliable source. Maybe it's a forgery, or maybe it was found somewhere else, does not belong to that epoch in the chronology. Then we have to consider what kind of processing can I do on this noisy data before I use that. So we have to apply logic and do things very, very carefully. Then even in the methods, we have to do some critical thinking. We have some assumptions in data analysis. We have to articulate those assumptions and say, does it make sense when I'm going to derive something of the Bharatiya civilization? How appropriate are the algorithms I'm using for analysis? If I'm using some semantic algorithms, if I'm using some genetic algorithms, mathematical algorithms, is it suitable or not? I have to say that. Modeling assumptions. Sometimes people assume so many things in the model that it's not at all a real life scenario. So we got to understand what the assumptions are. Then we need appropriateness of the model for the phenomena at hand, because you're studying some phenomena. Is that model good enough to study that phenomena? So you have to try and see if that will work over there. Then we need to have some inference or framework assumptions. What kind of drishti am I going to apply? If I'm a communist, then I want to see everything in Bharatiya civilization as oppressor, oppressed. That is the framework that I have. If I'm a Bharatiya civilization person, we are people in search of the truth. So we go in a scientific way to try and see what is the evidence telling us. So it depends on we have to talk about that too. What is the framework you've used? Then we have to see, do the frameworks consider alternate hypothesis? For example, if you say this data is describing this only in this way, maybe there's a different explanation for the same data and outputs. So we should do the diligence in saying these are the alternative scenarios, and you rule them out saying this is not possible, this is not possible, this is what I want. Finally, are the conclusions logical outcomes of the methods? So this is what we need to do for critical thinking of the data, of the methods, and so on. So in this entire series of lectures, I'm going to be presenting an indigenous model where there were archaic and modern humans in India for an exceedingly long period of time. If this is true, we must have Indian genetics going out of India and little coming into India in various time frames. Do we have evidence of that? That is the kind of question we must ask. Then we are making a point that languages, religious thoughts co-evolved cooperatively in India, and we can also show that religious thought and language went out of India. Then we claim there are outward migrations in various time frames and directions. We have to show now through the northwest, south, east, southeast, we have to show what kind of migrations were there. Then we can show that knowledge systems, trade, and practices co-evolved. They depended on each other for propagation and so on. Between both north, south, east, west of India and out of India, these forces were there. We have to show that. Then we can show that regional genetic mutations and language divergences have happened. This accounts for whatever diversity, little diversity, not much, that we're seeing in languages as well as in genetics. So we have to take the evidences and make inferences out of that. That is what we're going to do in this entire course over here. So before I start, let me try to give you a very big model. The model is from science. We want to say, how did we get here on Earth? That is a very big question. To answer that, we need models from many areas in physics, in biology, chemistry, in geology, and many such models are needed. But I'm going to show you this example to show you how we can use logic, rationality, and analyzing evidence to come with claims. This is an example of that. So first of all, we go to the very beginning. This is not the only model out there, but this is a model used by several people, and this is the so-called Big Bang cosmology. That is a model in physics which you use over here to say how we evolved to the present time. It posits that about 13.8 billion years ago, there was a very fast inflation that happened. That inflation is called a Big Bang, and somewhere around 380,000 years later, we had this cosmic microwave background. And around 200 million years after that initial inflation, that is when light, stars, galaxies formed. And now 13.8 billion years ago, we are here today with so many stars we see in the sky, so many galaxies that we see. This is what we say, and currently science posits that this happened in 13.8 billion years ago. And the model for this one is through the Big Bang cosmology. How did they infer this? Through the data. What kind of data? All the galaxies seem to be fleeing away from each other. So there's an expansion happening. So they work backwards and say there must have been a time when everything was compressed into a small point or so on. That's how this kind of model came about. Then today we got something called the fine-tuned universe. So here, as physicists are saying, there are some elementary standard charges, mathematical constants like elementary charge, constant of gravitation, Planck constant, speed of light in vacuum, electric permittivity in vacuum, magnetic permeability in vacuum, electron mass. These numbers are so small that you can see 10 to the power of minus 19, minus 11, minus 34. And they say even if it was off by a small value, instead of 10 to the power of minus 34 to 10 to the power of minus 33 in Planck's constant, the evolution of our universe would have been different. So they say that we have got a very finely tuned universe that owes its existence to these numbers the way they are. Once again, this is an outcome of astrophysics. How will time end? There are two theories over here. One theory says this expansion will go on forever and ever. It's an open universe model where eventually all galaxies will recede so far away from each other, we won't even see stars in the sky. Well, we won't be there anymore, but that's in trillions of years from now. That is one model of expansion happening forever. There is another competing model that talks about the big crunch. It says that as we go through a maximum expansion, some other forces of nature are going to come, dark energy, dark matter, and other such things will come into play. And we are now going to see in a closed universe a big crunch also happening, giving rise to another universe perhaps at a later point in time. But these are two very seriously discussed methods in astrophysics to try and talk about the fate of the universe using models of this kind. So in cosmology, we call this the big bounce model. In the big bounce cosmology, you have a prior universe, and this prior universe goes through an expansion. As it contracts, it goes through an expansion and starts a new inflation and a new universe of this form. So this is very intriguing for Hindus who also believe in a recurrent creation and destruction cycle. So it is very intriguing that even physics today is contemplating that there is a big bounce cosmology where we could have this kind of a recurrent creation and destruction of the universe in huge timelines. Then this is an intriguing paper that came about from Professor Roger Penrose, who's an astrophysicist in UK. So he brought about a theory that there is evidence for what he called Hawking points in the CMB, cosmic microwave background sky. So according to him, if you take a look at this picture on the left, it says that once you have this expansion event happening and galaxies taking root, after maximum expansion you have contraction, and this universe has got black holes in addition, right? These black holes will decide how the next universe is going to evolve. So in a sense, it's like Vasana, the Vedantic Vasana, where we say that our prior births, karma, decides what ruts we follow in the present life. We are drawn to certain habits in this lifetime because of the Vasana from the previous life. It's very intriguing that such a Vedantic concept can be applied to this also. The question to ask is, if the expansion event is uniform and symmetrical everywhere, why don't we see equal number of galaxies in the sky, equal number of stars? Anywhere we look, we must see symmetry. But we don't see symmetry. We see some places where there are more of these stars and galaxies, some places where there are less. And the reason for that, according to this theory, is because of some impact of the black holes of the prior universe controlling the evolution of the present universe. Then we can discuss, we have talked so far about the cosmic expansion, how it might, the birth of universe and perhaps the death of universe. We talked about the recurrent universe. We talked about Vasana in a sense. Now we got to talk about other things like supernova and so on. So what is a supernova? The model here is in stellar dynamics, in astrophysics. So this one says, initially for a 25 solar mass star, the fusion process inside stars converts hydrogen to helium, and that goes on for a long period of time, very stably for 7 into 10 power 6 years. When all of the hydrogen is exhausted, it goes to the second phase where helium is fused into carbon. That is for a shorter period of time. When that is also exhausted, carbon is fused into oxygen. That happens for just 600 years. What you're saying is the atoms are becoming bigger and bigger. Hydrogen is only one proton, one electron, right? You're only one over there. But by the time you go to helium, carbon, these are becoming bigger and bigger. And then oxygen becomes silicon in about 6 months' time. Then final stage, when silica fuses into iron, game is over. Game is over because in one day there's going to be a core collapse, and when that core collapses, we have something called a supernova. There are many kinds of supernovas, but we don't have to worry about that. What will happen when a supernova happens? Will it become a white dwarf, or will it become a neutron star, or will it become a black hole, depending on the kind of solar mass it has? And this theory, incidentally, is something called Chandrasekhar limit, one of the Indian scientists who proposed what will happen to a supernova given the initial masses of the stars. This is the kind of things that will happen. But for us, we are interested in this because when we have a supernova happening in a nebula, nebula is a collection of gases. So when you have a supernova happening over there, it's going to compress the gases over there, which can spontaneously ignite, fusion can start, nuclear fusion, it becomes a star. And so we believe that our sun also was born in some such supernova. Some supernova happened in our neighborhood and the gases collapsed and they started forming in the sun, and we had a protostar. And that is what we believe on how the sun came about. But what I want to show you here is that the material is recycled. So once you have this supernova happening, the material either becomes a black hole, neutron star, or some material is recycled in the nebula. It becomes another protostar. Once again goes to the main sequence to giant, supergiant, supernova, and so on. So this is like a reincarnation, if you will. I'm bringing in Vedantic concepts over here, but that is what this is. So the next question is, how did our solar system come into existence? So scientists use the accretion model in physics to talk about our solar system. It happened about 4.6 billion years ago, where some supernova in a nebula triggered the gravitational clumping, triggering the starting of the sun. In the neighborhood of where a sun formed, there must have been gases that clumped together with a supernova. It formed the proto-sun. And this proto-sun had also these proto-planets going around it, which collected together by the process of accretion. So the terrestrial planets built by collisions, accretion of infinitesimals by gravitational action, and the bigger planets formed by accretion of gases and they moved out to the outside, whereas the terrestrial planets are tied in more tightly by gravitation to the sun. That is what we see here. And then comes the next big question, how did the moon form? So we have the sun, we have the earth, how did the moon form? Well, today there is a model called collision hypothesis. In this collision hypothesis, a Mars-sized object called Theia collided with the Earth 4.5 billion years ago, and that collision resulted in the formation of the moon. So much of content went away from the Earth, coalesced around the Earth and became the moon. And that's what we think. We also think that Theia delivered water and perhaps comets also delivered water. And this one over here shows us that 4.5 billion years ago, the Earth formed and it was a hellish condition called the Hadean condition, a lot of volcanic activity and so on. Around 4,000 million years ago, that is when we had the first life coming on Earth. We're going to study this in a little more detail. So given that we know how Earth formed, how the moon formed, our next question is, how did even life form? How did life come on Earth? Well, none of us know for sure, right? But there are several biochemistry models over there, and one theory is called the panspermia theory. The panspermia theory says that life came to the Earth from outer space. It says that comets delivered the building blocks of life, amino acids and others, and it is through that, through the primordial soup, if you will, in some sense, life was triggered on Earth by the panspermia theory. And very reputed scientists like Chandra Wickramasinghe and others, Fred Hoyle, they proposed this theory. The second theory is that hydrothermal vent theory, that in oceans you got underwater volcano activity that brings in a lot of minerals like sulfur and other such things into the ocean bed, and that provides a conducive medium to form cells and reactions to take place and all kinds of cycles to happen. So that is also a serious theory, that hydrothermal vent theory. The third one is a primordial soup theory. This came about in the 1950s when a PhD student, he said, let's recreate the conditions of the early Earth in the lab. So in a test tube and flasks, he put the constituents of the early atmosphere the way they saw it, and they subjected it to lightning, day and night, to electrical sparking and lighting. And after about a week or so, he found that a tar-like substance had formed at the bottom of the flask and the test tubes and so on. On analyzing them, they found some of the biological molecules over there, which are biochemistry, you can say. Those kind of organic molecules is the word I'm looking for over there. So this theory says that life can form, in a sense, spontaneously if the conditions are right. If you had enough energy forming that, making all of these things, over millions of years, maybe the conditions would be right to form this kind of life. But what we know is that from 4.5 billion years ago, we first got water to the Earth. Water came through some process, maybe comets or whatever. And about 4 billion years ago, the earliest life came on Earth, single cell life, through any of these models for life that I've shown over here. And it went on to photosynthesis and others. I'll talk about this a little presently. The next big thing that happened on the Earth is the oxidation event. Earth did not have that much of oxygen to start with, so life requires oxygen the way we know it today. So if you go to 3.8 billion years ago, this graph shows you that there was very little oxygen content. But eventually, because of volcanic activity and other kinds of geological processes, oxygen started getting released into the Earth. And around from 3.85 to 2.45 billion years ago, there's no oxygen at all in the Earth's atmosphere. In stage 2, up to 1.85 billion years ago, oxygen was produced, but it didn't go to the atmosphere because the ocean would absorb it almost immediately and the seabed rock. Stage 3, it starts to saturate the oceans. So it gases out, but is absorbed by the land surfaces and the formation of the ozone layer. Stage 4 and stage 5, all the oxygen sinks are filled and the gas is accumulated in the atmosphere, making life conducive for us. As you can see here, for the last 1 billion years or so, we've had enough oxygen. How do we know this? This is from the geological model for oxidation. Even today we find these kind of fossils which are called stromatolites. These stromatolites are fossil evidence from 3.5 billion years ago that tell you about the oxygen content, cyanobacterial byproducts and so on. This is the tree of life. So we talked about several things about all kinds of life, how life came about and various mechanisms and so on. So there are scientists today who try to see the roots of life. Some root is here, we don't know. Maybe about 3.8 billion years ago, there's some single-celled organism and root. And we have about 3.22 billion years ago, we have the family of bacteria, a whole lot of bacteria over here. Then 3 billion years ago, we have something called the archaea. Archaea are single-celled organisms that lack a cell nuclei. So this is the family of those things. And we have what we call the eukaryotes. Eukaryotes are organisms whose cells have a nucleus enclosed within a nuclear envelope. Like all of us, our cells have got a nuclear thing. So you can see over here, plants are here and animals come over here, we come somewhere over here as part of this chain. So there are a whole lot of biologists who try to study our relationship to other living creatures, and this is the model they've come with for the tree of life and how life came about on Earth. Then we know that approximately 540 million years ago, the Earth went through an explosion of life, and that explosion is called the Cambrian explosion. So this one, we know that because the model uses fossil records. All over the Earth, we have found different fossils of early animals and other things that lived, and we can see that a whole lot of different animals, from sponges to jellies to where we come from, the chordates and so on, ones with the backbone and other such things, mollusks, worms, everything came during the Cambrian explosion. Suddenly, nobody can explain why this happened, but all of a sudden we had enormous amounts of life forming on the Earth, and the model again is fossil records. We also know from geology and others that Earth has gone through mass extinctions, many mass extinctions by the fossil records and other such things. So we have had about 400 million years ago, 365 million years ago, 252 million years ago, 200 million years ago. Then now the latest one was when the dinosaurs died out about 66 million years ago. And we are currently going through what is called the Holocene extinction event. It started about 12,000 years ago to the present time, when most of the species are dying out, as you can see. So this is perhaps by man-made activity, we're killing out a whole lot of life on Earth, and we're going through a new extinction. So again, science is the one that brings us all of this evidence on what is happening. This picture here shows you in a graph how life even came about. From the Big Bang explosion, we are seeing that 13.8 billion years ago to 4.6 billion years ago, the sun is ignited. Later on, the Earth forms 4.5 billion years ago, the moon forms, then single-celled organisms come, then we got atmospheric oxygen that comes, eukaryotes 2 billion years ago, bacteria, protozoa, sponges, corals, then by the time we come here, tetrapods, insects, amphibians, the Cambrian explosion is over here. Then by the time we come here, you got reptiles and dinosaurs about 0.3 billion years ago, birds, mammals, and flowers and bees, and primates. We belong to the primate family. We just came on the scene 0.01 billion years ago, and several Homo sapien artifacts have been found. And here's where we are as a so-called civilized society with writing. Very, very recent, as you can see, in the huge timeline of what we call how life came about. Why am I showing you all these things? I'm showing you because I want to emphasize the importance of models, that scientists always use models to explain these big questions. Even if it's a big question, how did I get here? As far as science is concerned, we will start with cosmology, we'll start with astrophysics, from there we'll go to geology, from there we'll go to biology itself, cellular biology and so on. We are able to use models intelligently, making use of the data that we can measure, whether it's expansion of galaxies, whether it's a fossil record, whether it is some other DNA record or whatever, we can use that data in different models and answer questions. So I'm giving you this big example to show we are using the same methodology to talk about the deep history of the Bharatiya civilization. Then we have got a strange situation where people observed that fossils were got in different parts of the world, but they all seem to be similar. For example, the fossil of this animal, a dinosaur kind of thing, was there in Africa and South America. This fossil is found in Africa, India, and Antarctica. This in Australia, Antarctica, and so on. So people questioned, how is it that the same animal is there in different parts of the world? The same dinosaur fossils appears to be there in different parts of the world. That is when people speculated that maybe there was a time when the continents were all together and the notion about continental drift came about in geology. So that explains why we got similar fossils in different parts of the world. And we know about continental drift about 1 billion years ago. We had the Rodinia, where proto-continents from 4 billion years ago coalesced into a supercontinent. We can see India over here, Madagascar connected to East Antarctica here, and it broke up about 0.7 billion years ago. And going forward, we know about Pangaea, Gondwana land, 225 million years ago, 150 million years ago, and you can see 100 million years ago, India has parted with Africa, Antarctica, and Australia, and starts off in the Indian Ocean and eventually lands up into China and to Asia today, forming the Himalayas. So these things have come to us because of the geological model called a continental drift or plate tectonics. That is what helps us to understand these things. Our next, we are stopping at various points over here to understand how we got here. So we talked about continental drift, we talked about fossils and other things. How did we as the primates get here? So the ancestral primate, according to the theory of evolution, the model here is evolution. The ancestral primate was there about 60 million years ago, where we have a common ancestor with the chimpanzee in the present times. There's a common ancestor with that and the lineage that gave to humans. Then going to different fossil records, we find various things, and by the time we come to Homo sapiens, our common ancestor is with over here with Homo erectus, giving rise to Neanderthals on one side, Homo sapiens on the other side. Neanderthals have died out, but we live on. So this is a model of primate evolution. And then we can, artists have tried to say this is how we'd look if we are reduced to an ape-like feature. The early Homo sapiens, not sapiens but specimens, look perhaps like this, which is more like a gorilla and so on. Eventually you get more and more human-like features from Homo erectus and Neanderthals and to Homo sapiens itself. So it just gives you an idea of how we have evolved over time. Then we have to answer the next big question. How did humans go all over the world? There's a theory that humans should have evolved perhaps in Africa. From Africa, how did they disperse throughout the world? And to do that, people study various things, the climate, evolution, dispersal, by looking at things like global climate transition, regional changes, amount of dust in the air, and what are the dry periods and wet periods. By looking at all of these things, they propose that these are the various Homo specimens that left Africa and went to various parts of the world in various periods of time. So the thinking is today that dispersal happens when the environment is not conducive for life. Either there's a drought in Africa, so you go to where water is and such things. Today we have got human fossils from all over India, not just humans, even Homo erectus and so on, from 4 million years, 1.6 million years, all the way to river valleys like Indus River Valley and other such things. We got specimens. So we know that Homo specimen has spread all over the world in these last 4 million years or 3 million years. We have spread all over the world. So our conclusion here, how did we get here? So I tried to answer that question using science to illustrate the use of models. And now what I've shown to you is, first we started with the model of cosmology, the expansion, so-called Big Bang, and so on. Then we talked about how the sun forms and how stars form. We talked about that model. Then we talked how did the earth form through the accretion model, how did the moon form through the impact model, how did life come? 3 models are there for life. How did oxygenation happen? Models for oxygenation, we talked about that. Then we talked about evolution, how multicellular life gave way to organisms. Then we talked about continental drift, extinction events, how from primates we have an evolution to humans, and how the climate change model can be used to discuss about dispersal, how humans went all over the world. So this is a huge model, if you will. There's not one model but many models that try to discuss how we got here. And this prelude was necessary because I want to go from there to the next big question. Archaeology, paleontology, in India itself. So I'm going to focus on that. Starting from the very big questions, we're now focusing on the regional geographical area called India. Well, scientists love to give these periodizations. I'm not too thrilled with it, but because this is their literature, I've reproduced it here. But I myself don't believe in such periodizations. So we got Paleolithic, which they say is a lower Stone Age from 2.8 million years to 150,000 years, and upper 45,000 years ago. Mesolithic, after the Ice Age 12,000 years ago. When agriculture was formed, we had the Neolithic 10,000 years ago. Then when copper is invented, this Chalcolithic 6,000 years ago, bronze from 5,000 years ago, and so-called iron from 4,000 years ago. Archaeologists love to put it in these kind of ages because it helps them to calibrate things in other parts of the world and so on. But region by region, these periodizations differ. It's not one standard that is there throughout the world. This is a paper that came out in Science in 2011. This is by researcher Shanti Pappu and her co-researchers. They said there was presence of early hominins in southern India going back to 1 million years ago. She found implements like hand axe and things of that nature, which they analyzed in the laboratory using optical simulated luminescence. That's a scientific way to study the age of that, dependent on several electronic properties. And she has calibrated this to 1 million years ago. That is in presence of human specimens in ancient southern India is 1 million years ago. And this is an example of such a hand axe is there in a museum in Haryana, if I'm not mistaken. It's in a museum in Haryana. We got this hand axe. So these are the ones that are about 1 million years ago. 1 million years ago, we know Homo sapiens did not live then. So what was the specimen living? Well, science tells us, again looking at the fossil record, that the species was called Homo erectus, and this is an artistic representation of what the Homo erectus might have looked like. We know they lived in social groups, we know they used fire, and their cranial capacity was between 750 to 1100 cc, and their habitat was Africa, India, Southeast Asia, and other such places. They used stone tools about 50 to 70 kgs, about 6 feet tall. So we know about them in this manner. And we are also told, because we don't find them in the fossil record, they say Homo erectus died out about 600,000 years ago. We don't find them in the fossil record anymore. But then this paper came once again from Shanti Pappu a few years ago, where she said that in Athirampakam in Tamil Nadu, now she found tools that are 385 to 172,000 years ago, with evidence that these are probably made by modern human brains. So she said it reframes the out of Africa models, because we are told that modern humans came out of Africa about 80,000 years ago, 85,000 years ago, out of Africa in the genetic models. But then she says the discovery of these artifacts in southern India opens that question whether that is a true thing or not. And you see here examples of those artifacts that have been found. A whole lot of interesting tools. Some tools here got long cutting edges. If you have a long cutting edge, you can scrape the flesh out of the skin of the animal you killed. If you have another kind of cutting edge, you can tear the skin. If you have another kind of cutting edge like a javelin or an arrow, which will pierce the animal. So this kind of tools requires advanced thinking, complex planning. Even before something has happened, the human or whoever made this must think about the application. I need something for that application. Look at a stone that they can fashion, that I can use this stone, and then start shaping it so that they get the final shape. All this calls for superior cranial capacity, which is typically associated with human beings, Homo sapiens, and not with earlier specimens. So this is intriguing that some species was living in India 350,000 years ago that was capable of very advanced tool making. Then this is the Narmada man, a skull that was found in Narmada Valley about 1982, dated anywhere between 300 to 150,000 years ago, Arun Sonakia. Initially they thought Homo erectus, but then this French investigator measured the cranial capacity and said it's about 1400 cc. That is very similar to the modern Homo sapiens cranial capacity, whereas the average for Homo erectus is 1000 cc in China, Africa, and elsewhere. So Kenneth Kennedy, American researcher, he analyzed this specimen and he said this has got to be an early Homo sapien. So here we have evidence that there were some kind of Homo sapiens living in India, early man, already in 300,000 years ago. It is not only the out of Africa model that's relevant here. So there are also researchers today who think there was one more specimen called Denisovans, and they are the link between ancient humans to modern Homo sapiens. And the name Denisova is from this cave in the Ukraine area where specimens were found, and that's what they refer to this as. So the Denisovans are probably some people who are in this lineage that we see here. You can see with interbreeding and so on. They're leading to the present day modern humans. So you can see this timeline over here, 40,000, 30,000 and so on. But we are now talking about even earlier ancestors who lived 300,000 years ago. Some people feel that this is what the Denisovans were. And over here, this is a Greek archaeologist, Katrina, who in 2019, she estimated that the Denisovan cave oldest specimen lived about 195,000 years ago. So clearly the timeline is very close to the Narmada man and such things. So we believe that maybe this is the age of this particular specimen. So this is a graphic that tries to show how these Denisovans had perhaps evolved at some particular point. They went to Denisova cave from India, and from India went all of these places. And during the ice ages, whenever the water was locked up in ice, they were able to move around. And they're supposed to be the link between the old human being, Homo sapien, and the modern Homo sapien. But again, these are all cutting edge research, so there's no definitive answer as yet on these things. We are interested in archaeology in India. For the last 50,000 years at least, we know for certain these are Homo sapien artifacts in India, and all over India we have got these artifacts. Whether you go to northern India, eastern, western, southern India, all over the place you have artifacts that are found Son River Valley, BS River Valley and other river valleys. We have got different implements that tell us that yes, human presence was there in India all over the place. It's not just concentrated in one area and not in the other. So we know that India was a populated country for a very, very long period of time. That is our inference from here. And this is a paper that came out in 2020 in Science Advances. And they found in a Sri Lankan cave, they found a bow and arrow that dates back 48,000 years ago. This is the first instance of weapons outside of Africa found in, so the technology probably has come to India around this time frame, and they're referring to that technology here. And these are examples of the different spearheads and points they found in this cave. That shows that whoever is living here 48,000 years ago was capable of making these arrowheads and other such things. Then this is something that came out in BBC News some time back, and this said that specimens were found in Maharashtra, which the scientists are dating anywhere from 48,000 to 12,000 years ago. These are some of the kind of stone tools, some specialized tools, including some kind of petroglyphs, which you can't see if you're on the ground, but if you take a drone with a video camera and go up into the air, then you can see these patterns. So these people had some complex rituals. They were making these patterns on the ground and other such things. That's very interesting to see this. Then we have got artifacts from 35,000 years ago in Jwalapuram. Jwalapuram is near Kurnool district, and this rock shelter shows continuous occupation, and some of the tools that have been found in this particular area are shown over here. So I'm showing you various instances to show archaeological finds, paleontological finds in India. Then this is a paper that came out in 2020 in Current Science, and the researcher here is Professor Ramaswamy from Bharatidasan University in Trichinopoly. And the uniqueness about his research is he conducted underwater sonar mapping. So his theory was that if there are some artifacts under the water also that belongs to ages gone by, and he went from not today's Pumpuhar, but 15 kilometers outside the Bay of Bengal. This is the shoreline, present day shoreline. 15 kilometers out, about 125 meters down, he found there are human artifacts over there. He found an ancient harbor, settlements, and so on. So this coincides very nicely with the last glacial maximum. In climatology, we know the last glacial maximum happened around 18,000 years ago when most of the water was locked up in ice, which means the shoreline would have been visible far beyond where they are today. And maybe that is what he's pointing out. The shoreline in those days would have been somewhere here, and the humans living in this area of Tamil Nadu today had ancient harbor. Harbor is very intriguing because it says even 18,000 years ago, people had a marine culture, maybe going by boat from one port to the other, maybe from Tamil Nadu to Andhra, from Andhra to Odisha to Bengal and other places. Maybe they're hugging the coast and going. But very interesting to see, maybe there was trade, maybe there was some kind of marine contact already happening here, or maybe they were just fishermen going out fishing and coming back. We don't know. There's not enough data to tell us one way or the other. This one is again showing to us the various settlements over here, what is called A, B, C, D and others. He's trying to show, for example, past shorelines 20,000 years ago at 125 meters depth, 15,000 years ago at 110 meter depth, 11,000 years ago at 50 meter depth, 9,000 years ago 25 meter depth, 8,000 years ago 20 meter depth, 7,000 years ago at 5 meter depth. So in other words, the sea is reclaiming, right? As the ice is melting, the water levels are going up, and he's showing instances where people have relocated their living places. So he's found artifacts in all of these areas showing that the city that we call Pumpuhar today was relocated so many times because over the ages, water levels were going up over thousands of years. This also tells us that people who are living in this part of India had settled over here for long enough and were willing to reconstruct their capital every time we had submergence events over thousands of years. Then we have ancient artifacts from Bhimbetka 35,000 years ago that even shows a horse with a rider. Probably Indians have already domesticated the wild horse. That is what we see over here. They've already domesticated the wild horse, and you're seeing a rider on a horse over here. In Edekal caves in Kerala 9,000 years ago, we're seeing something that looks like proto-writing. Ketavaram, Andhra Pradesh 8,000 years ago, we got rock art. In Haryana, Virana, we are seeing evidence of artifacts from 10,000 years ago. Ramachandrapuram, Telangana 12,000 years ago. So what this is telling us is in various periods of time, I've started from millions of years ago to 300,000 years ago, gone to 40,000 years ago. Now I'm showing to you in the various ages, we got all kinds of artifacts. Then this was published by Deccan College in Pune, where they're showing rock art in Maharashtra that's at least 10,000 years old. Once again, you can't see it from the floor when you're standing on the ground. You need to take a drone with a video camera and go up. Then you see all these complex patterns of humans, of animals, and other such things shown on this. This is implying that these are not primitive people who lived there, but they have some kind of a culture, some kind of religious practice, some kind of common things that are bringing them together to make all these kind of huge artifacts. This is a newspaper article that came out reporting ASI finding 12,000-year-old artifacts near Chennai itself in this case, where they found multiple layers, Paleo, Neo, Sangamira, Pallava era, going back 12,000 years, the various stone tools, artifacts, and other Sangamira works 2,000 years ago with Roman shards, glass beads, Pallava from 1,200 years ago to 1,800 years ago with Shiva, Vishnu, sculptures. Amazing to see a continuous occupation of this place for a pretty long time. Then in northern India, we got Birana that is showing to us that various archaeological artifacts from different cultural levels, from the very ancient one from pre-Harappan Hakra, 9,000 years before present, all the way to mature Harappan, we got artifacts over here. So you can see even 9,000 years ago, we got artifacts that have been recovered from places in Birana. This is a paper that came from the Deccan College, and this paper tried to see the Saraswati Sindhu settlements and tried to find many ancient settlements were found. If you look at this map, you see this dotted line. This dotted line is the course of the Saraswati, and the strong line is the Indus today. So in those days, the Sutlej used to feed into the Saraswati river, and it's a strong flowing river. But then 1900 BCE, we had plate tectonic movements, because of which Sutlej, instead of feeding into Saraswati, started feeding into Indus River, starving the Saraswati, in other words. Similarly, Yamuna, which is also feeding to Saraswati, now was captured eastward into the Ganga. So because of these reasons, Saraswati became a dried up river, but we find a lot of settlements over here, and these researchers wanted to do radiocarbon dating in these places to see how old are some of these settlements. And I've highlighted in yellow the oldest radiocarbon dating they have done. This is in Mehrgarh. In Mehrgarh, the oldest samples are 9,385 years plus or minus 120 years before present. This is the radiocarbon dating that has come from Mehrgarh. Pretty ancient. Some of you may wonder, what on earth do we have such an ancient civilization? But we see the antiquity is supported in later lectures. I'm going to talk to you about astronomy. In astronomy, you'll find that it hints great antiquity in our Brahmanas, Upanishads, and so on. And that is being supported here by radiocarbon dating from Saraswati Sindhu civilization. So it's not fantastic. That is the bottom line. And archaeogenetics also shows mutations in this timeline and so on. Kalibangan, some of the oldest samples we have are 6,700 years before present. Same paper talks about that. Rakigadi, some of the oldest ones are around 6,180 years before present calibrated age. And Birana, some of the earliest samples are about 7,570 years BCE or 9,500 years before present. That is the kind of samples we found in Birana. Some of the oldest samples we have found in this entire region we call Indo-Pakistan area. Some of the oldest ones have been found in Birana, clearly showing to us that this area has been occupied for a pretty long time along the Saraswati river basins. This is a paper that came out in Episodes in 2003. In this paper, the researchers from National Institute of Ocean Technology in Chennai, they went to the Gulf of Cambay because they wanted to lay submarine lines. They wanted to map the floor with sonar mapping. And as they were doing sonar, they found evidence of a major structure under the water, which is a 9-kilometer long feature 40 meters below the sea level. And they believe it is not natural, but maybe man-made. Perhaps it could have been a seawall or some such thing. They also got a piece of wood, a carbonized wood, which they sent for carbon dating to Germany as well as in Hyderabad. And they came back with a date of 8,500 years to 9,000 years before present. Of course, there are some people linking up with Dwarka, the sunken city of Dwarka. It's intriguing to know, even in eastern part of India, we have evidence from Professor Ramaswamy's work. Western part of India, we have evidence from this work that even in the marine areas that are underwater today, we have got underwater artifacts that show the antiquity of the Bharatiya people. This is a research paper that came out in 2012 that tried to show evidence for the Saraswati River and the capture of the Yamuna River. So they wanted to show, by analyzing the mica and the sands and so on, they wanted to show how did this Harappan culture suddenly die? What kind of weakening happened? In addition, the drying up of Saraswati and so on. And so using zircon, they came with evidence that the Saraswati River, the capture of Yamuna to the east in the Ganga and the loss of Sutlej to the north to Indus, that rerouted water away from the Saraswati River. And that is what led to the drying up of the river itself. This is one more paper that came out in 2019. You must understand now that many scholars who don't want to admit the antiquity of Indian civilization deny the existence of the Saraswati River. So they say Saraswati River was mythical. That is one thing they say. Or they say it's a river somewhere in Afghanistan which Aryans encountered on their way to India. That's why they mentioned Saraswati River in the Rig Veda. Because think about it, if the Rig Veda, in the linguistic analysis, the Rig Veda was composed in India after the so-called Aryan invasion in 1500 BCE, how can the Rig Veda talk about a powerful Saraswati River? Because it is already dried up by 1900 BCE. So we have problems over there. To address these problems, some of these researchers who don't like the antiquity of the Indian civilization because of these linguistic analysis and things like that, so they position this as a mythical river. That is why it is necessary for our scientists today to say, excuse me, it's not mythical. There is scientific dating that can tell you there was a river over there. And this is one such paper. The previous one was also one such paper. This is also one such paper in 2019 in Nature Scientific Reports that is saying there was a perennial river. Perennial means flowing throughout the year. So by analyzing the white mica sand, they found evidence 3 to 10 meters below the surface, both sides of modern Gagar in a stretch of 300 kilometers up to the Pakistan border. Presence of the sand is a powerful indication of a powerful river in the past. And this paper says this river had two distinct perennial phases. One phase was 80,000 to 20,000 years ago, and the other phase was 9,000 to 4,500 years ago. So by 4,500 years ago, this river is gone. It's completely dried up. And today we have found dozens of settlements along the ancient river mentioned prominently in the Rig Veda. If you look at this map, you find this dotted line. This dotted line is the paleo channels of the Saraswati. It is paralleling today's Indus path, as you can see. In those days, the Sutlej used to feed into this river, and Yamuna also used to feed into this river. But now, after plate tectonics, Yamuna is flowing eastwards, and Sutlej has been caught in this northwards, and so this river has become dry. So that's how we know Saraswati ran dry. Then there is evidence of pottery records. People said that if you find a new kind of pottery in the material layer, archaeological layer, that is indication of a new technology. The new technology might come because some new people have come to this area. So many people propose that for this Aryan invasion, if people had to come to India in 1500 BCE, we must see a change in the pottery record where the Aryans bring their technology, their way of making pots. And so they went about looking for evidence of that one. And they said it is ochre colored pottery, OCP. This is the pottery associated with the so-called Aryans, which they said is available in India from 1500 BC and so on. But this paper and many other papers dispute that aspect, saying that this ochre colored pottery actually is there from 4th millennium BCE, approximately 3000 BCE up to 2000 BCE. It's not something that came with the Aryans, but it's already there in the material record even before the so-called Aryans came. Bottom line, you cannot use OCP as an indicator like this particular picture has tried to present the OCP at 1700 BCE to 1300 BCE, but that's bogus because we're seeing it from 3000 BC onwards, we are seeing OCP in the record coming till here. So one has got to be careful when we read some of the works over there, because there are researchers who don't want to analyze the evidence because they want to go with models that have been established, like the linguistics model. And so they have to deny some of these evidences. But we are logical, rational people. We seek the truth in the civilization. So we look at the data, we look at the models, we look at the assumptions, we look at the evidence, then we come to conclusions. Our conclusion here is that OCP is there in the archaeological record from 3rd millennium, meaning you cannot associate this with the so-called Aryans who came in 1500 BCE. Then there are many, many artifacts in more recent times. Harappa, look at all these beautiful artifacts found in various layers, 3500 BCE, 1800 BCE. Then we have got archaeologically in Sanauli, which is just north of New Delhi, we have found not one or two, but many chariot burials. And the archaeologist on duty is saying these are not donkey cart chariots, these are not bullock cart chariots. He's saying clearly these are horse-driven chariots. Additionally, he's found evidence of shields of men and women both fighting with helmets, shield, with swords and other such things, showing these are war chariots. War chariots are not bullock carts. Bullocks won't move that fast in a battlefield. It's got to be horses. So this is tentatively dated to 2200 BCE and so on. That's telling us about the antiquity of some of these. It's an interesting piece of evidence we'll come to once again when we talk about Aryan invasion. We'll look at this evidence once again. What about southern India? We already saw stone tools in southern India 1 million years to 150,000 years, stone tool adaptations 125,000 years to 40,000 years. Now, I don't believe some of these datings because these are done by foreigners. For example, this man, Japanese professor, Concise History of Southern India, he's tried to show Neolithic only came 5,000 years to 3,000 years where food grains, settlements, ceramics are found. But then we got evidence of people living in places like Pumpuhar 18,000 years ago, indicating they're a marine kind of people. Maybe they were settled in some way, if not in agriculture, maybe some primitive herding, maybe some primitive fish culture was certainly there, allowing them to be settled and so on. So we have to question some of these assertions over here. And obviously, all over southern India, including eastern India, we find megaliths, menhirs and dolmens, which has been tentatively dated to this time frame, which again I don't believe for several reasons. For example, we have got all over southern India, we got megaliths, maize, menhirs, dolmens. This is from Koppal in Karnataka, which the date has been put at 3,000 years ago, but please don't use that. It shows these huge granite structures, and we have a megalith labyrinth in Dharmapuri that's showing a maze over here. And we have these menhirs in Erode as well as in Arunachal Pradesh, stone circles in Pakistan, we see the dolmens in Kerala, we see the stone circles in Andhra Pradesh also. So all over India, I just showed a small sampling here, we find these things. But what is intriguing to me is this is common not just in India, but a worldwide culture that is showing these things. For example, these are from Europe showing these menhirs. This is from Wales, this is from Brittany and Ireland, from France, Sardinia, Eritrea, in Manipur in India, in Czech Republic. We see a similar cultural artifact that seems to show a hero stone or a gravestone, some kind of an evolution. But my point is, it is common throughout the world, implying there's some cultural contact in ancient people also that shows this commonality. The same thing is there in dolmens too. Dolmens have been put by some people are dated to 5,500 years ago, but again, doubt this, it's probably much earlier. This is in Cornwall. Look at the architecture. It's the same as you find in India. Cornwall, this is in Cornwall, this is in Kerala. See how similar these things are. This is in South Korea, France, Ireland, Germany, Sicily, Quebec. These are all the same structure. So how do people in different parts of the world have the same architectural dolmen? Again, is it an independent evolution, or is there contact between these ancient people who we are dismissed as Mesolithic people who are not civilized and so on? Some problem is there. Stone circles, scientists have dated them to 11,000 years to 5,000 years. In Göbekli Tepe in Turkey area, we find this ancient Göbekli Tepe. We find this in Golan Heights. You find this in Senegal, the famous Stonehenge in England and Brittany, in Mongolia, Telangana, in various other parts of the world, we find a similar culture once again. So these things must set us thinking what exactly is happening in the ancient world, so that even massive architectural remains have been found like this. These are things that one man can't do. You must have several people coming together, cutting a stone, lifting it up and making these structures. So this was a cultural activity that required a community to come together and do it. And this is a technology that has gone throughout the world. This is a picture that shows Iron Age in South Asia, Japanese professor from 2018. And what we see is the oldest iron in India is in Gachibowli in Hyderabad, University of Hyderabad campus, 2200 BCE. Then you find Brahmagiri in Bhadravati in Kerala, Karnataka and other places. You find a lot of iron. It's some in Tamil Nadu, and you find Andhra Pradesh. And what is interesting over here is we find the oldest iron artifacts are in southern India. And as you go towards the north, 1100 BCE, 1300 BC, 1800 BC, and in northwest over here, 1200 BC, we are finding that this technology is going from south of India, it is going towards the north and out of India. This is intriguing because if the Aryans had come to India from the northwest side, carrying iron with them, as told with the linguistics model people, then we expect that this northwest India must have the oldest iron and the technology must come to the south. But we are seeing a reverse flow over here, saying iron is in the south, oldest iron, and this technology is migrating northwards. Very intriguing to see this picture. Edakal caves, like I said, there appears to be proto-writing itself over here, including connections with Harappa. From Kerala to Harappa, there seems to be some marine culture because of commonality in some of the symbols over here. This implies these are not isolated primitive people living here, but people who have contact with each other and trade perhaps. Adichanallur in Tamil Nadu, we have found urn burials, gold diadems, iron implements, including a bronze of something called Mother Goddess. Now, I thoroughly dislike that word because in India, we don't know what Mother Goddess is. We only know what Shakti is. So, Shakti is a word we've used in the civilization for thousands and thousands of years. But at any rate, we have a bronze of Shakti in 1500 BCE, and several other artifacts have been found in Adichanallur. Kiradi outside Madurai today is interesting because we found similarity of the cultural artifacts there with Harappa. For example, here's a terracotta pipe similar to what we find in Harappa. There are brick walls and floors over here, very similar to Harappa once again, flooring, walls and other such thing. So this has got people asking, did we have a urban culture that was not just in northern India, but also in southern India, sharing technology, sharing means with each other and so on. A lot of intriguing things are here that support that. Some of the artifacts found over here are shown. And some of the early Brahmi writing also appears to be in the pottery shards over here, including evidence of jewelry and other such things, weaving industry, bone points, dice, game, just like you find Harappa, you find dice for games, game heads and things like that. You're finding similar things here, showing that people had a leisure in addition. It is not just living life and dying. They also had a leisure where they enjoyed life. That's what it's telling you. It's an urban culture over here. There are several people who are trying to date Kiradi, but I think that we have not heard the final word. Right now, the research that's come out says that it is perhaps 600 BCE is the earliest layer that has been found from Kiradi, but it doesn't mean that's a terminus layer. So we have not found carbon artifacts that can find greater antiquity in Kiradi. My thinking is Kiradi perhaps can be bracketed between 821 BCE to 2974 BCE. But I'm positioning this purely on a mathematical study, which is not very accurate, but it is a first approximation, if you will, that will tell us about the dates. Perhaps in the future we might find cultural artifacts, carbon content in Kiradi that will tell us how ancient this is. Perhaps we'll find that it's got connections with Harappa and other such things. Then this is a port that is there outside of Pondicherry today. It's called Arikamedu, and Arikamedu is mentioned in a Roman sailor's document called Periplus of Erythraean Sea, where they used to trade in dyed muslin, glass beads and so on. The archaeologist Mortimer Wheeler in 1945, he dated it to 100 BCE because he found a bust of Augustus Caesar there. Vimla Begley, another researcher in 1989, she said the date has to be revised to 200 BCE at least. But then she could not dig any further because the groundwater was contaminating. She says in her diary that she could not dig any further because she was under the water table, and so she could not proceed. Anyway, the glass beads from Arikamedu is found in Bali, Japan, dating to 300 BCE and earlier. This shows that we had a maritime trading culture on the eastern side of India going back to great antiquity. Then when the tsunami hit southern India, it uncovered a lot of interesting artifacts. One of the interesting artifacts is a temple 2200 years ago. Why is this important? Because there are people today who say that southern India does not have evidence of Vedic practice or other such things, but then we have a temple here going to 200 BCE itself. So this is an interesting piece of evidence that can come to show that. This is a map from my good friend Jijit Ravi, who's trying to show where are all the places that are of India that are mentioned are itihasas, epics and others, and he has painstakingly detected this geographically and has put these names over here as references to our itihasas. We can see that places in India and outside India are referenced in this particular picture. Very, very interesting because it is showing that our epics are deeply tied to the geography of the land, and our epics are aware that people had settled all over India in a pretty long period of time. However, we don't consider epics as sources of history thanks to the way the British have written our history and the received wisdom by our leftist academia. We don't consider any of our epics as sources of history. But in the textbooks like NCERT, we study this. We say that between 5,000 years ago to 3,600 years ago, we had this Indus Valley civilization here, but nothing here. Rest of India shown as empty lands. You can see how ironic it is because I've shown here going back from 1 million years to the present time how India has been a settled place genetically, archaeologically and elsewhere. But this is what we're teaching our children. Very criminal way of distorting the true history of India. So our conclusion on the antiquity of humans in India, we have shown today human habitation continuously from more than 1 million years ago. We have shown Homo sapien artifacts from 30 to 40,000 years ago. We have shown detailed artifacts from 10,000 years ago. Southern Indian cultural artifacts from very ancient periods of time, but I've gone with the dates that people have proposed 5,000 years ago. Common menhir dolmen stone circle worldwide culture, but then our textbooks are showing a shallow understanding of the antiquity of human presence in India. My suggested reading are these things. You can read this paper that talks about the Dwaraka, about the carbon dating and others. This is by Katiroli and others. Or you can read Dilip Chakrabarti is a modern archaeologist who's worked in India and his work on Hinduism from prehistory to early history. Or you can read this book by B.B. Lal, who's showing a commonality of the Indian civilization, how deep are the roots of Indian civilization. Or you can also read this book where I'm talking about how science tells you how Cambrian explosion happened, terrestrial or cosmic. All those kind of ideas are over here. How did life come on Earth? Did life come on Earth from Earth itself, or from outside of Earth. Those kind of discussions happen in papers like this. So this is my suggested reading for this particular lecture. So with that, we have come to the end of lecture 1 and lecture 2. In future lectures, I hope to go in much greater detail on various aspects of the Bharatiya civilization. Thank you. Namaste.